So today we're going to take a look at a couple problems from homework 5.4, which involves solving quadratics. So right now we would look to see if we could factor, and if we can't factor, we're going to have to complete the square. So as I look at number 7, there are no factors of 1 and 2. That would give us a -5 in the middle. So that means we're going to have to complete the square, which means I'm going to make a PST. So to make a PST, I'm going to go ahead and add something to this side to make it a PST. And there's a couple options. This time I'm going to add it to the other side to balance. So I know what's unique about a perfect square trinomial is that when it factors, the two factors are exactly the same. So if I'm multiplying this out to get an x squared, I need x and x. I know that I'll need both minuses, so I have to think about what number do I add to itself to result in a 5. Well, that would be 5 over 2 and 5 over 2. Because 5 halves minus another 5 halves would be -5. So then I work backwards to figure out what and that would belong in our blank here to make it factor into x minus 5 halves, x minus 5 halves. And so I simply multiply the -5 over 2 times the -5 over 2, which is 25 over 4. And I'm going to go ahead and add that on the other side as well to balance. And so that means I have x minus 5 over 2 squared plus 2 will equal 25 over 4. Now, I am solving, so I'm going to go ahead and get x by itself. So I'm going to subtract 2. So that's what? 25 over 4 minus 8 over 4. So 17 over 4. Take the square root. Whatever comes out of a square root must be positive, and I don't know if x minus 5 halves is positive or not, so I will need absolute value. I cannot simplify square root of 17 any, and the square root of 4 is 2. So from here, I would make my piecewise. I know that an absolute value equation results in a piecewise function because absolute value has two sides to it. Also notice that this 5 over 2, that would be our axis of symmetry of our parabola. Now I write my two equations. X minus 5 halves equals root 17 over 2, and the opposite of x minus 5 halves equals root 17 over 2. I solve for x. X equals 5 over 2 plus root 17 over 2. I'm going to divide by a negative. And then add. So notice my solutions. 5 halves plus root 17 over 2. 5 halves minus root 17 over 2. Those are conjugates of each other. The other that I had asked a couple times is question number 9, and so I look to see if it will factor and it will not, so that means I'm going to complete the square. I'm going to leave the -3 alone, and I'm going to factor out the 2. And the reason I want to factor the 2 out of these first two terms is because it's much easier to work with a PST where the leading coefficient is a 1. This time I'm going to add a blank. And just to be different than the last problem, I'm going to then subtract that blank on the same side in order to balance. I'm also going to draw this arrow over, which tells me whatever I choose to put in our blank is actually being multiplied by 2. So at this point is where I think backwards. I think about how would x squared minus 4x plus something factored. So I would need an x and x, minus and minus, and to get a -4x in the middle, I would need a -2 and a -2. Now, what does that mean I put in this blank? Well, -2 times -2 is 4. Even though I have placed a 4 in our blank, that 4 is really being multiplied by 2, so I have a net gain of 8 there. So I'm going to turn around and subtract 8 from the same side. We now have this equation in vertex form, and you could graph it using transformations if you wanted to. From here, let's solve. So I'm going to add 11, divide by 2, take a square root, so I get absolute value of x minus 2 equals, root 11 doesn't simplify, root 2 does not simplify, but we learned early on in the semester we do not like radicals in our denominators, and so I'm going to choose to rationalize that and multiply by root 2 over root 2. So I get root 22 over 2. I'll need a piecewise because I do know that absolute value has 2 pieces to it. And I use my piecewise to write my 2 equations. X minus 2 equals root 22 over 2. And the opposite of x minus 2 equals root 22 over 2. And I know my solutions will be conjugates of each other. A few of you asked about number 14. So one of the things that as I look at this, I see about number 14 is I have this equal to 0. So I know what I do to one side, I can do to the other. And so that means if I want to get rid of the fraction, I can certainly do so. And I'm going to kind of approach this 2 ways. So I'm going to multiply both sides by 3. That gives me 0 equals x squared minus 12x minus 6. From here, this does not factor, so I'm going to complete the square. X squared minus 12x plus something. And then this time I'm going to go ahead and just minus that on the same side to balance. So as I look to factor, I know I'll need x and a minus and a minus. So then I ask myself, what number do I combine with itself to give me 12? Well, that would be 6. And negative 6 and negative 6 is 36. Now I know x minus 6 squared minus 42. And I think if you watch the rest of the videos, you could probably solve from there. Now, in saying that, I'm going to address this problem in a different way. Let's say that this was equal to y, or to f of x. And here I would not want to multiply by 3 because then I would have 3 f of x. If I want to complete the square here, I would factor out the 1/3. Don't forget that that blank is going to be multiplied by 1/3. And so I would actually end up with the same PST here. So I would have 36. But 1/3 of 36 is 12, so minus 14. So I get 1/3 x minus 6 squared minus 14. That's what I would use if I were graphing this problem. And someone said, what would I do first? Well, really, the only order that matters here is you have to do your vertical compression before you go down for 14, because those are both changing your y values. So that's the order that would matter.